In the last class, we discussed about vectors and types of vectors and then vector operations. Now in this class, we are going to discuss about the resolution of vectors. Okay. So why resolution of vectors are important? Now in this topic, we are going to discuss and how the resolution has to be done. The things we are going to discuss now. Okay. For example, let us consider you are the person who is traveling only along x-axis. Clear? You are traveling only in one dimension. Let us say you are traveling along x-axis. Now what is the direction of you means your direction is I cap. For example, let us say you are moving only along y-axis. Clear? If you are moving only along y-axis, clear? Then your direction is j cap. For example, let us imagine you are moving in xy plane. If you are moving in xy plane, then we have the effect of both the components. Clear? Then we have the position or displacement at each and every point depends on two components, x component and y component. Clear? For example, if I take a person who is traveling from origin to, for example, let us say phi. So the person travels from origin to phi. So he traveled only along x-axis, let us say 5 units or 5 meters. For example, if the same person is going to walk along the y-axis, let us say for example, he is going to walk along the y-axis, let us say he walked up to, for example, 10 units. If he wants to travel only, or if he travel only on y-axis, clear? If he travel only on y-axis. Now, if he is moving in the xy plane, clear? If he is moving in the xy plane, at each and every point, his position depends on two coordinates. That is, from the x coordinate and from the y coordinate. Clear? That can be represented as x comma y. Okay. For example, let us imagine you have two mirrors. The two mirrors are placed perpendicular like this. Clear? The two mirrors are placed perpendicular like this. Okay. If two mirrors are placed perpendicular like this, and if you are moving in this direction, clear? And if you are moving in this direction, then your image will move along this mirror and your image will move along this mirror. Clear? Your images will move along the two perpendicular mirrors, but you are moving in this direction. Clear? For example, you are moving in this direction, but your images are moving along x-axis and along y-axis. Therefore, your velocity or your position is having two coordinates at each and every point. Clear? So you are having two coordinates at each and every point. Okay. Therefore, your motion is specified by two axes. Clear? So what is your velocity along this axis and what is your velocity along this y-axis or these two axes will give the velocity of you at that point. Clear? For example, if I want to find out the velocity of you at this point, now I have to define the velocity along this axis and the velocity along this axis. Then I can able to find out the velocity at this point. I hope you understood. Therefore, in order to find the velocity along this axis and this axis, we have to resolve into two components. Are you clear? So that's why vector resolution has to be done if a body is moving in a plane. Clear? If the body is moving in more than one dimension, then resolution has to be done to know the values along each axis. For example, I will take this as xy coordinate system and I will take this as origin. Clear? I will take that as origin. For example, I will take this point. Clear? I will take this point P. Clear? I will take that point P. Now, I will take this as a vector R bar. Clear? I will take this as a vector R bar. Are you clear? Or else I will take this as, for example, vector A bar. Clear? I will take this as vector A bar. Now this vector A bar is making an angle theta with the x-axis. Now what is the angle made by this A bar with the y-axis means 90 minus theta. Now this vector is having two components at any point. Now let us say this point. At this point, what is this having means it is having two components. Let us say these are the two components. This is the x component, this is the y component for the vector. Now I will take this x component of the vector as ax. I will take this y component of vector as, for example, ay. Okay. Now direction of x-axis I will consider as I cap, and direction of y-axis I will consider it as j cap. Then the vector a bar is represented as ax. So ax is along x-axis and x-axis direction is I cap. Plus, if you consider this vector only along y-axis, or if you consider this vector along y-axis, this can be taken as ay into j cap. Therefore, at any position, the vector a bar consists of both x component as well as y component of values. For example, let us say a body is moving only along x-axis. We already discussed that. So if a body is moving only along x-axis, then you can take that a bar is equal to ax into I cap. If a body is moving only along y-axis, then a bar can be taken as ay into j cap. Now this is only along one dimension. Now this represents the two dimension. Okay. Now ax is component along x-axis. Clear? Component of a bar along x-axis. Now what is ay means? Ay is nothing but component of a bar along y-axis. Now I hope you understood. Now listen, I will use the geometry to explain this. Trigonometric formulas to explain this. Now this is the vector a bar. This is the vector a bar. Now I will consider this point as, for example, n. I will take this point as, for example, n. So if you see this triangle, so that is triangle OMN or MON. So from the triangle MON, this component is ax. We already know that. This component is ay. That can be taken like this also. Why? Because means these two are parallel. So from that triangle MON, what is the tan theta value means? Tan theta is equal to ay by hypotenuse. This is a. So I will take that hypotenuse as a. Now a bar is a vector, a is a magnitude. So we already learned that vector a bar can be taken as a into a cap, where a is the magnitude. Now I will take this as a. Okay, sorry. I will take sin theta. So if I take sin theta, then sin theta is equal to opposite by hypotenuse. So opposite is ay by a. Now from this, I will write ay is equal to a into sin theta. So I will take this as equation number 1. Now from the same triangle, that is MON, from the same triangle, I will take cos theta is equal to, cos theta is nothing but adjacent side by hypotenuse. So what is the adjacent side means? Adjacent side is ax. So adjacent side is ax by a, or else ax is equal to a cos theta. So I will take this as equation number 2. Now square and add equation number 1 and equation number 2. If you square and add the equation number 2 and equation number 1, then you have ax square plus ay square is equal to, I will write this as a square sin square theta plus a square cos square theta. Now if you take a square as common, then sin square theta plus cos square theta is equal to 1. Then ax square plus ay square is equal to a square. Or else a can be taken as square root of ax square plus ay square. Now this is the resolution of vectors in 2 dimension. Okay, now from equation 1 and 2 I will take equation 2 divided by equation number 1. If I divide equation number 2 by equation number 1, then equation number 2, or else I will take equation number 1 divided by equation number 2, then you have ay by ax is equal to a sin theta divided by a cos theta. Now cancel a and a, that implies sin theta by cos theta is tan theta. The tan theta is equal to ay by ax. That implies theta is equal to tan inverse ay by ax. Now this is about the resolution of vector in 2 dimension. Clear? So if a body is traveling in more than 1 dimension, to explain the position velocity of that body, you have to consider its effect along the remaining other axis. That's why we have to do the resolution. For example, if you take the resolution in 3 dimension, for 3 dimension you will get ax I cap plus ay j cap plus az k cap, where ax, ay, az are the components of vector A along x-axis, y-axis and z-axis. Now, based on this, now we are going to discuss about the next concept, that is position vector. For example, I'll take an xy coordinate system. So this is an xy coordinate system and I'll take this as origin. I'll take a point P. Clear? I'll take the point P. Okay. Now, where P is the position of a body or position of a vector. Now I'll take this axis as x-axis and I will consider this as y-axis. Now x-axis direction is taken as I cap and y-axis direction is taken as j cap. Now I want to find out the position of the point P. Now remember, the position of this point P can be represented with one vector. That vector is taken in this direction. That vector is taken as OP bar. Clear? So that vector is taken as OP bar. Now listen. To reach this vector, clear, to reach this vector, you have to travel along this axis. Let us say travel through a distance, for example, small x. Again, to reach this point, I have to turn towards y-axis and I have to move along this and I have to reach the point. Let us say along this axis, I travel distance y. For example, in your room, let us imagine one point. To reach to that point, you have to move to the corner of the room. From that corner, make some steps 1, 2, 3, 4, 5. So you just move along the y-axis like this 1, 2, 3, 4, 5. After that, turn like this 1, 2, 3, 4, 5. Then you will go to a particular position. Clear? For example, if I take this as a graph, if this is your room and this is your floor of the room, clear? I want to move to the bench. To move to that desk or bench, I have to move from the corner. Let us say we are moving from the corner. From corner, I have to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 steps along x-axis. You can move 1, 2, 3, 4, 5, 6, 7, 8, 9 along y-axis. Then you can reach that point. Now what is the position of that point? Means, for example, 10, 9 is the position of the point. Or else you can directly take the displacement of this point like this. So displacement is nothing but shortest distance between 2 points. Now this is called as a displacement vector, or this is also called as a position vector. Clear? This is called as a displacement vector, or this is also called as a position vector. The displacement vector or position vector is taken as OP bar. Clear? OP bar. That OP bar can be taken as, now along x-axis I moved distance x. Along x-axis its direction is I cap. Now along y-axis I moved a distance y, therefore y. what is the direction of y-axis means j cap. Now the OP bar is nothing but position vector which is taken as xi plus yj, or else directly you can write to OP like this. I will take this as, for example, r bar. Now I will take r bar is equal to xi cap plus yj cap. Now this is the position vector or displacement vector in 2 dimension. Clear? This is the position vector or displacement vector in 2 dimension. For example, if I take the 3 dimension, if I take the 3-dimensional space, I will take this as x, I will take this as y, and I will take this as z. Now I will consider one point in the 3-dimensional space. Now let us consider fan of your room. Clear? Let us consider fan of your room. Now start from the corner of your room. So you move along x-axis, for example 5 meter, and move along the y-axis, let us say for example 3 feet, and we can't walk like this on the z-axis. Let us imagine along the z-axis, for example, our fan is at a height of 12 feet. Now what is the position vector of your fan means 5 feet along x-axis, 3 feet along y-axis, 12 feet along the z-axis. Actually, I given one example. In your room or in your home, these position vector values may changes from point to point. Now, as a physics student, you have to explain the position of any body like this with these coordinates. For example, you can ask your mom, or you can ask your friend, or you can ask your brother like this. So, my watch is at the position coordinates 5, 5, 3. Okay. Now, bring to my coordinates which is taken as horizon. Clear? So, in physics language, you can speak like that instead of go and bring my watch. Clear? So my watch is at the position vector 5, 5, 3. So please bring me to the 0, 0, 0. You can explain like that. Okay. So here in 3 dimension, I will take this as a point. Now to reach to that point, we have to move along some distance along x-axis, some distance along z-axis, some distance along y-axis, and finally I have to reach to this point. Clear? So some distance along x, some distance along y, and some distance along z. So finally, the position vector is taken from origin to this point. Clear? Origin to this point. That I will consider as, for example, r bar. Clear? That I will consider, for example, r bar. Now, that r bar position vector OP bar can be taken as xi cap plus yj cap plus zk cap, where k cap is the direction along z-axis, I cap is the direction along x-axis, j cap is the direction along y-axis. Okay. Now this can also be taken as r bar. That r bar is equal to xi cap plus yj cap plus zk cap. Okay. Now the magnitude here r can be taken as square root of x square plus y square, as we discussed earlier. Here also magnitude r can be taken as square root of x square plus y square plus z square. We are going to discuss about the laws of vectors. We are going to discuss 3 laws in these vectors, that is triangle law of vectors, polygon law of vectors, and parallelogram law of vectors. First, I am going to discuss about the triangle law of vectors. So triangle law of vectors. So what is meant by triangle law of vectors means? It states that when 2 vectors, so let us say the 2 vectors as a bar and b bar. Now this a bar and b bar represented by magnitude and direction. So vector means vector is a physical quantity which has both magnitude and direction. Therefore these 2 vectors are represented by magnitude and direction by 2 sides of a triangle. So by 2 sides of a triangle, for example, if you take this as a triangle, I will take this as a bar and I will take this side as, for example, b bar. Now a bar and b bar are the 2 vectors represented by magnitude and direction by 2 sides of a triangle. These sides has to be taken in order. For example, what is you mean by order means the first side, that is first vector, head is connected to tail of the second vector like this. So this is the order. Okay. Now for example, if you take the third order, the order will be like this. So the arrow will be in downward direction. But according to the triangle law of vector, the resultant is taken Clear, the resultant is taken along the third side. Clear, the resultant is taken along the third side or closing side of the triangle. So this is also called as closing side of the triangle. So the resultant is taken along the closing side of the triangle or third side of the triangle. Okay, third side of the triangle or closing side of the triangle, but in opposite direction. So opposite direction means like this. So this is the resultant, and this is about triangle law of vectors. Now next we are going to discuss about the polygon law of vectors. In polygon law of vectors, we have a number of vectors. Clear? So a polygon will have number of sides, therefore will represent each side of the polygon with a vector. Therefore, if number of vectors are represented in magnitude and direction by the sides of a polygon, that too, these polygons are taken in order. For example, I'll take this as vector A bar, and I'll take this as vector B bar, I'll take this as vector C bar, I'll take this as vector D bar, and then so on. Clear? These are the vectors. Now the closing side of this polygon, clear, the closing side of this polygon. So this is the closing side of the polygon. Now this closing side of the polygon represents resultant. Clear? The resultant is denoted by the closing side of the polygon. So closing side of the polygon. Okay, but taken in opposite order. So this is the opposite order. Now this closing side represents resultant. Now next we are going to discuss about the parallelogram law. The next law is parallelogram law of vectors. So according to the parallelogram law of vectors, if two vectors are represented in direction and magnitude by two adjacent sides of a parallelogram, for example, I will take the two vectors A bar and B bar. These two vectors represents two adjacent sides of a parallelogram. Then the resultant vector is given in magnitude and direction by the diagonal side of the parallelogram starting from the common point of the adjacent sides. For example, I will take this as vector A bar. I will draw one line parallel to vector A bar. Now I will draw another line parallel to vector B bar. Now these two vectors combine to form a parallelogram. Now A bar and B bar represents two sides of a parallelogram which are making an angle theta. Now what is the angle between the two vectors means theta. Now the resultant, clear, the resultant is taken along the diagonal side of a parallelogram. So the resultant is taken along the diagonal side of the parallelogram, that is taken as R bar. Now listen, this resultant is taken from the common point of the two vectors. Clear, that resultant is taken from the common point of the two vectors. That resultant R bar is taken as, or that resultant R is taken as square root of A square plus B square plus 2AB cos theta. So this is the parallelogram law of vectors.